What's up? Welcome back to linear algebra. Let's jump into Augie. I'm blinded by this light. Blinding. That's why. Alright, what must be true of the diagonal entries for a diagonal matrix D to be invertible? It must all be non-zero. How are the columns of a matrix A affected if it is multiplied on the right by a diagonal matrix D? The columns of matrix A are affected if it's multiplied on the right by a diagonal matrix. Each successive column is like basically you take the row and multiply it down through it. Successive entries. So each column is multiplied by successive entries. Successive columns of A are multiplied by successive diagonal entries of D. Good. If a diagonal matrix D has diagonal entries D1, D2, dn, and if K is a positive integer, what is D to the power of K? Each of those entries is to the power of K. What is an upper triangular matrix? An upper triangular matrix is a matrix in which all entries below the main diagonal are zero. Oops, I didn't know you could do stuff like this. Okay. A lower triangular matrix is a matrix in which all entries above the main diagonal are zero. Triangular matrix in general is either an upper or a lower triangular matrix or both. If an invertible diagonal matrix D has diagonal entries D1, D2, Dn, what is D to the inverse of D? It's basically each of the entries to the power of -1. What must be true for a triangular matrix to be invertible? The main diagonal entries in the main diagonal must all be non-zero. What is a diagonal matrix? It's a matrix in which the entries above and below the main diagonal are zero. Yep. How are the rows of matrix A affected if it is multiplied on the left by diagonal matrix D? Basically, it's like you take the successive row. Each successive row is multiplied by a successive diagonal entry. Oh, that's it. Okay. So let me try to recall, I guess. I don't think somehow I missed yesterday as well for linear algebra because I was sick, making up other stuff, so. Okay, what were we learning about? Vector transformation. Is that right? Vector transformation? Oh, domain range, codomain. Okay. Function. So a function is essentially you take inputs of one set, then they go into a codomain, another set. A function is a rule that converts numbers of one set to numbers of another set, in which for every number in the every number in the first set, there's exactly one output for that entry, or for that number in that set. So boom, that's a function. The domain is all the set of inputs, I believe. The codomain is all the set of outputs, and then the range is actually a subdomain, or a subset of the codomain. And there's a subset where I don't know what that is. This is the first time I've learned about codomains. All right, that's good enough for now. Let's check it out. All right, I forgot two things. Index and image have to do with like say f of a equals b. What do we say the image is? This is how the range relates. Okay, hold on. Functions and transformations. So intro to functions, transformation, images, values, domains, codomains, and ranges. Function is a rule that associates each element of one set to exactly one element of another set. That was good. B equals f of a. Image B is the image of f under a. Value f of a is the value of f at a. Okay, the value is simple. Domain is a set of A. Set A is domain of F. Set B is codomain of F. Range is a subset of the codomain. Good. Consists of all images of elements in the domain. Image was B. All images of elements in the domain. Okay. All right. Transformation. Ooh, this is something I missed. AKA maps, where T is a function with domain r to the power n and codomain r to the power m. T is the transformation from r n, I don't know what that is, rw, rn to rm. Transformation is called an operator when n equals m. Operator on the domain. I think this is just a slip of the pen here. Okay. I'm going to continue learning, and then I'll be back to recall what I learned in a little bit. All right, guys, so what did we just learn about? Matrix transformations. So now we know what matrix transformations are. So they kind of walked through, basically, you got a set of linear, we're going to be focusing on matrix transformations for linear systems. So take a linear system, put it into matrix form, and then you can say that matrix form is basically equal to what? B equals A times X, right? And so we can say, another way we could say this is that this is a transformation, matrix transformation from X to B, and the transformation is multiplying on the left by A. So we can say that the transformation is T to the subscript A to denote that it's being multiplied by A, and then we can put in X into there, and that's going to lead to an arrow maybe, and then B. And so this is basically, there's a way to say it, but if we wanted to denote it with the the domain and the codomain, we say T to the sub A colon R M, R to the power M, then an arrow R to the power N, and I think I got a little bit clearer on what the domain and codomain are. It's R to the N, so like R squared would be all of the ordered points. It's like the degree. R cubed is every potential 3-point coordinate in 3 space of real numbers. And the codomain is all of the same thing, except it's not the same thing unless R or M equals N. The domain is, the range is a subset of the codomain then. It's all the possible outputs from the function that exist in R, or the codomain, we'll call it. Just a zero transformation. So T to the sub 0, that's a zero transformation, essentially like multiplying by 0. It will give you basically a 0 vector. It can be from Rm to Rn. Identity operator though is T to the sub I, and this is like multiplying by I, and it's an operator because it's always going to lead to the same size or degree R. So M equals R. All right, transformation, matrix transformations. T sub 8 maps X into B, we'll say. Matrix transformation can be written as W equals T sub A to the X, or of X, or TA colon Rn to arrow Rm, or their schematic form. X arrow, TA above the arrow, and then B. Okay. All right, that's it for today. All right, yeah, I also got 7 more flashcards done for 1.7, so there's only 1 more to do, and then we'll be fully focused on 1.8. Should be starting tomorrow, so which is what we're working on. But that's it for today. Talk to you tomorrow. See you.